Hey, oh. Me when I don't have anything up on screen ever. How's it going? How's it going? I am gonna do some fluids. I decided to, oh, this problem. Okay, I'm gonna just restart this. Okay, I'm not gonna restart the conservation of mass. We'll keep that. But I'm gonna restart this problem. Why did I have so many? Why do I have so many? I mean, sure. Okay. I'm gonna restart most of this problem. Anyway, we're doing fluids. Hi, hello. Wait, let me get my tablet out. There we go. So game plan is we do this, we do thermo, and then, well, thermodynamics, so work stuff, basically. And then, sorry, work and energy, heat transfer. And then, if we can, a little bit of Navier-Stokes. Exciting. We just did that today, so like, disclaimer, very bad at it, but that's okay. I was thinking about this problem. Hey, I finally joined a stream. Oh my gosh, nice to see you. Yeah, normally I stream a little earlier, but I'm gonna be streaming even earlier over the summer. But I'll probably do some later streams too. Yeah, you get to experience the Demon Mic live. Oh god. So I was thinking about this control volume, and I was like, I don't think this is good. Well, the other thing I was thinking about is I looked at the provided solutions, which he almost never gives. Fluid dynamics? Yeah, we're doing fluids today. Oh, my music is not capturing. That's so. Oh, I just turned it to a vertical layout. How do I get 1 second. There we go. My god. Property. Oh, it is. It's just really quiet. Yeah, we're doing fluid dynamics. This is control volume analysis, so it's not actually too. Oh, it just paused. It's not actually too hard to think about, I would say. We basically have one sort of equation, and then we just keep track of stuff going in and stuff going out. It's pretty much all we do, and we just cross out terms depending on assumptions that we make. So the kind of two things that that we're changing is this one. We're not gonna have the weight active of O. We're gonna say that the weight is negligible. So no weight. Weight of water plus pipe is negligible. That's gonna simplify things actually quite a bit. Negligible, yeah. Get out of there, get out of there. And that was pretty much like the only thing I was like really getting annoyed with. But the other thing I was thinking is, so we're trying to find, so we have this pipe, there's a jet going through it, the jet's being directed, so there's a force that's happening, and actually a torque also. It doesn't ask for the bending moment, which is the first sort of like question mark thing that I was thinking about, because on this other problem that we were also taking a look at, this whistle problem, we were trying to find the tension in the shear, but also the bending moment in the pipe. So, you know, that to me screams angular momentum conservation, because we have a torque. Also, I realized, like, when I say torque, I try to really say torque. There's no way for it to not sound like torque. It has, the words are basically the same word. Anyway. But yeah, there's gotta be some weird little thing, because so if we sum forces in X, we're gonna have these two reactions, even if we do this other control volume, because I was thinking about control volume selection. If we were to take a free body diagram of this link right here, we would have the reaction forces at this pin up here, and we would have the reaction forces at the pin down here. And obviously, if we're trying to take that internal, we would cut, and then we would have, like, you know, the reaction forces here, and then we would have that sort of internal cheer and tension. I was the weight character called Miss Scale. Oh, Sexy A? Yeah, exactly. So the issue is a lot of the times we just oh no, did Demon Mike happen? Fuck. Well, sorry. That welcome to the stream. Oh, okay, good. That wasn't a Demon Mike scream. Maybe it was, I'm not sure. Yeah, either we neglect weight a lot, so Sexy A is not unfortunately a recurring character. Although there are other recurring characters. Other fun little guys. But yeah, we can take the internal forces either from the top of the link or the bottom of the link. So I chose the top of the link, which puts our control volume right along this line, which means we also are looking at O there. But we could take the control volume that it goes through here. Or we could take the control volume that it goes like here, I guess? Like something like this, where we're like only taking that. And I don't know if that would work. But in my mind, I'm like, I think maybe because we're cutting through this, there'd be reaction forces here too, though. Because I was like, oh, well, we could just do this, and then we could just do angular momentum, linear momentum summing, and then it would just be one thing. But then I was like, that sounds kind of like it shouldn't be possible, but I can't say, like, why it's not possible. I think it's probably because we have to, as I draw it out now, I think it's because we're cutting through this support as well if we were doing that. Or the ground, and then that would have a cut there. So we are going to do, we'll do angular momentum conservation, which makes sense because it is an angular momentum problem set problem. And if we take the moment about O, we can get FCY, which is the one that it says. But like, how do you get FCX? You just can't. How? That's my big thing. Like, sure, I can get FCY. I think I got FCY when the weight was there, even. Yeah, see? Right here, I have FCY. I'm pointing to it. Can't point to it. I have FCY right here. But... Also, why did I sum linear momentum? Oh, wait, I might have to do it. Okay, maybe... Well, on a moment, we don't care about FCX. Let's do this. Let's do it. I'm gonna move this. I'm not gonna get rid of it. I'm not gonna delete it, but I'm gonna move it. So we don't have to look at it. So we can try to do angular momentum conservation first and see if we have everything we need. Angular momentum. So the angular momentum equation, we need position stuff, which means I'm taking the moment about O, I'm moving the origin. I didn't know if I was going to take it about, I mean, I shouldn't have taken it about C ever, but let's just be silly with it. Okay, so we need a R vector there, so that'll be like RC from O. Also, the fact that it's called O probably is a good indicator that it's about the origin, that should be the origin. Well, I don't know why it's called O. It's called C because there's A and B. Learn about the alphabet. Okay. Let me take a look. Me when I forget the angular momentum. I think it's just R cross V's, but I just want to make sure. Let's see. Let's see. That is a nothing. Wait, I lied. That is the something. Here. I've never seen people name vectors R. It stands for... What does it stand for? Why do I do that? That's a good question. I think it's because... It's... like a radius? Maybe? I don't actually know. But, like, the moment arm. I guess it's because usually we tend to use R for positions. Here we use it for lines. Ah, interesting. Yeah, like when we do, when we locate, like, points with a vector, we tend to call that their, like, R vector. I think it's because, you know, from the origin to the point is sort of like a radius. I assume that's why. But I don't know. Okay, so we have torque applied plus, what the heck? Why did I write that? Yeah, we got it. I was like, what am I talking about? Okay. We don't have any applied torques, so it's 0. Okay, so we have the sum of the applied torques plus the sum of the Fs. Okay, so our Fs, we are gonna have an Fs. That's gonna be our RC with respect to O crossed with RC with respect to O crossed with FCY. Plus, I'm just gonna see R cross FB, which is 0. Yeah, because if we add a R is rect for my logic. Ah, yeah, that would do it too. I'm actually interested. Why do we use R for position vectors? Position vector R. R for radius. Yeah, radial vector from the origin to the location. In short, we do not need a position vector, as its usefulness as an auxiliary quantity diminishes as you get to more advanced physics. It's funny. I feel like in engineering, oh my god, I was going a little insane today because my professors have done this. 3 of my professors have done this. Maybe 4. But both of my civil engineering professors, who are good, did this. And they were talking about, like, they were like, oh, this is like a stress tensor. And, like, my professor today, he was like, oh yeah, this describes, like, a tensor. And I was like, oh, I didn't think we did tensors in undergraduate level stuff. Because to me, a tensor is, like, a nested array, right? That's, like, past 2 dimensions. So you have, like, a vector, and then you have a matrix, and then you have a tensor. So, like, a 3-dimensional matrix, essentially, is, like, a tensor. But so I asked him about it, and I was like, hey, so, like, you use the word tensor, like, do we have, like, 3D, like, 3D stuff? And he was like, no, we just call things that are bigger, that are higher dimension than vectors, tensors. And I'm like, okay, I see how it is. I wouldn't make that choice, but, like, go for it. I guess they just call, I feel like it's so funny, because I feel like engineers are, like, actually really allergic to math. And I'm like, guys, why are we still writing things with, like, IJK hats on them? Like, that, maybe let's put on some adult pants and make them into vectors. I feel like that would be a lot easier for everybody, and then we don't have to write a bunch of IJKs and a bunch of vector hats on them. Because you just write a vector, and then that's your vector. I don't know what to say. We're civil engineers, making it all and losing credit to architects. Okay, I say because, like, at least, like, in my university, like, we have a couple we have a very specific, like, disciplines, and so civil engineers don't actually do a lot of, like, stuff with architects. Those are architectural engineers, because our civil engineers tend to do things like, oh, I need to locate my velocities as well. Civil engineers tend to do things like, you know, like retaining walls and bridges and roads and stuff like that. And then architectural engineers also do, like, retaining walls, but they'll do more, like, residential stuff. So I think it, and they also do, like, design. They take a lot of architectural courses. So, and it's a 5-year program, just like architecture. So I don't think they, like, either I think they don't do that much in terms of the design, or they, you know, they're actually involved and they get credit, I think. Or that's the way that I think about it. Did I write anything in that thing? No, I didn't. Awesome. That's conservation of mass. Let's not do that. This is r cross v. It's gonna be 0 anyway. Try to cross out the specific thing that's 0 just in case anybody's interested in that. Okay, so this is... We need our first location for a velocity vector. I don't really know... I think we have to locate... Let me just check. Pretty sure we have to locate all our... Oh, that is not the right CV. Oop, it's the other page. Yeah, so we have to locate our velocity vectors, but I'm actually not really sure how we did this. Oh. I guess we just said they're like sort of in the middle of the pipes. Which... Well, maybe we didn't. No, we didn't. We... Oh, no, okay, yeah. Wait. No. Wait. What did I say? Okay, R1... Okay, we're gonna put a bunch of stuff in matrices quickly. R1 is L1. No. That one will be 0. R2. Negative L1, L2. Negative L1. I think we just say they act in the middle. Let's see. This piece of paper that I had. Sorry, everybody. Yeah, we're saying, okay. I'm gonna say, yeah, velocity vectors. I guess because it's an average velocity. Or we're integrating, yeah, you know, yeah. Oh, they give us the dimensions to the middle, so we'll do it in the middle. Okay, cool. Coolio. Should I just, like... Do we want to just pop this in here as a cross product? What are we feeling? That feels pretty awesome to me. Okay, we're gonna do R cross F. I don't like doing cross products like this either, but like, that's the way you gotta do cross product. Alright, so our R first for our V1 is gonna be up. We'll call this one L1. And then, should we over first? Well, we're not given an over from O, which is just, that's lovely. Did they really not give us that? We're just gonna assume that it's above O. It's clearly not. Okay. Good. Don't worry about it. Negative L2, L1, 0. And then our V2. And our V2 is in the X direction. I also write my cross products up and down because column vectors, I like them better. Sorry, gamers. I don't know why I wrote V2, that should be V1. And then I'm gonna just do this one in my head too. We have to do the v1.da1, so v1.da1 is going to be negative, so it'll be v1.da1. That. And then I'm just going to put one right below it, cs2, I, j, k, and we'll call this distance L3. And then this will be... I'm gonna just call it L4. We have a defined L4, but I'll put it in at the end. I don't really want to do that out by hand. Okay, so we're going positive in the X, which was our L3, and then negative L4. And then V2. It's at a cosine and stuff, so we're gonna say the X component is 9. And this one is negative. Row 1, row 2, V2, DA2. Alright, well, that was fun. Okay. Okay, sorry, everything was crashing for a second. Alright, so what have we got? We've got this duder as well. We can evaluate this one. Yeah. Cross product it up, why not? There we go. I know letters. Okay, this is L5. Algebra works for you. And then 0 FCY. I find it very strange that, like, that we're not really worried about the horizontal component, because it is a link. So, like, what's gonna happen is, right, this is gonna, as this wants to go this way, so it's turning this way, which means it's pushing this way, so it's trying to push this whole thing this way, and actually, maybe it wouldn't. I was thinking about, like, if it was gonna go this way, then it would want to turn down. And so, it would be in tension. Okay. Yeah. But yeah, if it turned, then this link could possibly turn, right? It would maybe go like this, if it was all the way down. But if it's up, it can't really go like the top of its up. The top of its up, if you will, is here, so it would just be sucking compression. Okay, attention. Okay. I'm okay with that. I love determinants that are easy. I'll do this one. So negative L5 and our what's it called? It's our, like, internal little. Okay, so that doesn't give me that. Let's do this one. Wait, does it actually? Yeah, it doesn't give me. Well, I don't know why I can do that. That seems wrong. Okay, so positive, negative. So negative FCY. And then our little internal. So I'm doing something wrong. What's up here? I mean, I know what it should be. It's gonna be FCY times L5. But why is this being goofy? What's up with that? It's R cross F. It's not F cross R. Holy shit! It's Damie. It's me. That's an X value. That's a Y value. What the hell is up? It should be the easiest cross product to do. Why can I? Huh? What? These ads are trying to recruit me into the military? Oh no, quick, say transgender. And then they go, whoa, no. I think I will go to the, no, don't go to the US military. Why can I not evaluate this cross product? What is happening? Oh wait, no, this is fine. What was I doing before? I was like, oh my god, I was crossing out the wrong thing. Jesus Christ, okay. Oh god, okay guys, it's fine, I'm so normal. It should be negative FCY times this. That way. Yeah, this does not make any sense that way. So we do 0 and then minus, so it'll be positive L5. Does that make sense? Let's see. It's a positive moment. Wow. Only took me about 1,000,000 years to do that. Jesus Christ. Okay, it's fine. Everybody has those days. Make the military come to you instead with this fun, simple trick. No! Oh no! It's like, my, professor telling us about how to make thermite. Don't make thermite, please. I'm not gonna talk about that on stream. I do think it's funny when professors are just, like, unhinged sometimes. It's the best. Okay, so positive, negative, positive. So V1 times negative, so negative L1 K hat. Ugh, K hat. Ugh, ugh, ugh. And then squared. Oh, we can pull a bunch of stuff out of this. I'll just leave it as V1, row 1, DA1, and we can start pulling stuff out. Okay, so row 1 can come out, the V1s can come out, L1 can come out, yeah, can come out. Okay, literally everything can come out. Equals, so negative V1 squared, L1. Okay, so it says this force is in the K-hat direction, which I'm a little worried about, because it should not be in the K-hat direction. But we'll cross that bridge when we get there. Unless there's a K-hat component to this that cancels out, and then our lives are great. This is the magnitude of this, by the way. I didn't multiply the component. What was my component there? Stop crossing it out that way, oh my god. Okay, K-hat. No, okay, we're chilling. Wait, why is it in the K-hat direction? What the, what? Oh, it's angular momentum. It's a moment, what am I doing? Of course it's in the K-hat direction. Lol. Okay, it's okay guys, I'm so good at engineering, I'm manifesting. Okay, neither one of these are good. I mean, I guess I could just cross product with the K. I lied, it's fine. Positive, negative, positive, and it's positive. Lovely. 2 terms though, so negative L3 V2 cos 30 theta. Change all those to thetas. We get that. We get that. That generalized equation swag. Okay, there we go. I can. Ooh, it's so close. Out of here. I also need. I also don't need to draw this like 5 arrows. I like to. It kind of looks like sheep just like jumping over a fence. I need to get rid of them though. We don't know. We know how to integrate here. You guys are good at that, right? We're all really good at integrals and math and all that stuff. Yeah. Okay, I also put no K-hats on those. This is all K-hat, so I can get rid of every K-hat. Awesome. I could have just done this with a moment, but that's... Paper Mario, oh yeah. I have on my stream playlist, I have a lot of Paper Mario because it's my favorite game. Not this one, but I do like it. It's a good game. All of them are good games. Okay, what can I take out? I can take out pretty much all this garbage. I can take out all this garbage. Okay. So we get L3. Nope. Negative L3 V2 squared cosine theta row 2. We can get rid of the row 1 and 2. I'll leave it for now, actually. So I did the V2 squared, and then A2, and then plus L4 V2 squared sine theta row 2 A2. Sticker Star is my fave, surely. I grew up playing Thousand Year Door, so I am not a like a die-hard, like essentially the same speed. Okay, so the V's are the same. A die-hard fan in the sense that I'm like, everyone must love this one and no one else can love anything. But it is my favorite. I actually did play Sticker Star though. A very small amount of Sticker Star. Which, you know, I remember enjoying. I don't think it's a bad game. Okay, I don't know if this answer is right. We can check if it's right. It might not be, although I really don't think it's that hard. Hopefully, like, this problem is I mean, if I didn't oversimplify it too much. It's just the horizontal components kind of weird me out. I'll have to check it later. If I get it wrong, then I get it wrong, but... Let's do, a way harder problem that I'm probably not gonna be able to solve. I enjoyed it as a kid, not gonna lie. I think it's fun. I think it's fun. I mean, people were super huge haters for Color Splash when it came out, and now people are like, oh, Color Splash is fine. I don't even remember why people didn't like Sticker Star. I thought it was like just some petty stuff, TBH. Alright, thermodynamics. Yeah, thermo. Whoa. Jump scare of 3 paragraphs of text. In lieu of assigning homework problems, consider attempting to solve one or both the problems. If you cannot solve these, you're encouraged to use the problems at the end of your textbook to select, okay, sure. No matter what problem you choose to solve, practice problem solving. Thanks. The first problem is similar in some ways to the example problem we covered in class. It involves a pump. It takes things one step further and incorporates fluid statics. It's a great entryway into pipe flow analysis. Second problem is a typical open system thermodynamics problem, so you can see the connection between what we were working on in this class and what you might have seen in thermo, which I have not taken. Because it did away with story aspect and expanded the world and levels things. It's super, Super Paper Mario? Or is that, oh, was it, what is there? Is there another Super? I'm trying. I would love to play Super Paper Mario on stream. I own it. I don't have like a capture card or anything, but that would be, oh my god, that would be so awesome. Oh, it's my favorite game ever. Maybe that's like when I like own a house, then I can play. That's my, that's my, not own a house, when I don't live in a dorm. You know what I mean? There's a helpful note if you had not have thermo yet that should not discourage you and you should still be able to solve the problem. Okay. Alright, well that's scary. What might you do to prepare? Thanks, King. Should we try the hard one or the easy one? Maybe we should do the easy one this time. This looks like it's already hard, so I'm gonna go ahead and we're gonna do the easier one. Do the pipe flow problem. Oh, so bad. Pipe flow, baby. Okay. We turned out didn't need that, actually. I'm not gonna delete it, I'm gonna leave it, just in case I get the entire problem wrong and then I have to do that again, and it probably is not unlikely. Alright. Kerosene. Kerosene, 20 degrees C. Probably gonna have to look up a density. Flows, well, it doesn't really matter, I'm just gonna call it density. Flows through the pump as shown in the figure at a volumetric flow rate. Okay. GPM, don't know what that is, but that's fine. Grams per minute, maybe? Head losses between locations 1 and 2 are 8 feet. Okay. And the pump is supplied with a W dot 8 horsepower. I hate horsepower, but that's fine. A U-tube manometer is used to measure the pressure difference across the pump. Under the conditions described, what should the reading H from the manometer be? Whoa, okay, there's a lot of stuff there. We're trying to find a pressure, which is a force. So, we don't really care about the manometer at all, actually. Let me turn this music down slightly so Paper Mario's not yelling. I love having non-normalized background music because it just gets louder and then really quick. Like, you can't hear any of the Pikmin music. Okay, the term head loss is considered the net result of internal energy change and heat transfer. Okay, we'll get there. Pickled men. Exactly. Alright, let's just think about stuff first. So we care about the pressure force. Right, there's a pressure difference, which means it's going to be two pressure forces that we're like subtracting, probably. We're probably going to have to do, well, I mean, we're going to do thermo. Which means, well... So what would we have to use? We know that we're given a W dot. And we can use that sort of like to find internal energy changes. I mean, I guess we can find the work done by that force instead of the individual forces. But whatever that means, we're gonna have to cut through some stuff. So I guess we'll cut here. And here? Yeah? And I need to connect them somehow. Okay, do I want to include the mercury or not? I kind of don't. What if I cut after the mercury? I feel like that would be bad though if I cut after the manometer. I think I have to cut before. Well, okay, I'm gonna do this. I'm gonna include like the pump. Ugh, that looks gross. Make bigger lines than that. Okay. And then I guess we might have to include the mercury, I'm not gonna lie. We know how much mercury it is? No, we don't. Also, I mean, we could say that it's just negligible. Probably what we're gonna do anyway. We also don't really care about the work from body forces in terms of this equation. I mean, we are gonna care about, like, we'll need to make a datum for our gravitational energy. Well, we get a head loss, so maybe we don't have to, like... Well, but internal energy change in heat. Okay. I guess we kind of want something where our thing is not, like, changing gravity, though. Or... aging. Gravitational potential. Let's make some assumptions. Steady flow. Now, okay, can we assume incompressible kerosene is a liquid? Flammable liquid. It's a liquid? Okay, we're just gonna assume it's incompressible. Alright. What else? We don't really care about area stuff because we're just working with Q's, so we don't really have to deal with that. I guess we can just start with conservation of mass too. I mean, we don't have to. Well, I gotta choose a CV. It's a hard choice. There's gonna be a pressure force if I cut across here. Is the reason why I'm a little bit iffy, but it is gonna be, you know, in the Y direction, which we don't care about. We could just kind of not sum it, but let's see what I did. So for the one that we did the water and through the shaft work that's happening. But we don't want that. We want... I mean, I guess we could just make it literally the pump. I mean, if we made it just the pump... I feel like the only weird part is, like, I feel like I have to assume something with the pressure across these sections. Like, I think we kind of have to say, like, whoops, forgive my absolute ripping up of this schematic. None of the numbers matter, it's fine. I feel like we kind of have to maybe assume that, like, the pressure here and here is the same. But it wouldn't be, is the thing. I mean, the pressure here and here would be the same, I guess. Unless it wasn't, but I mean, I think we might have to assume that. The pump is supplied with a W dot. Oh, wait, the manometer is used to measure the pressure difference across the pump. Okay, so yeah, we just want... I wonder why it's so, like... Why there's extra pressure, then. What do you want to just go across here, across here? Let's just do the pump, then. Because we're still gonna have, our velocities, I guess. Just going, like, this will still be V1 and this will still be V2. Yeah, I like that. Okay, we'll do that. We'll try that. Okay, we got our pump. So I guess we have a work in, we know that. Wait, is it a W dot? I think it's a W dot. Let's check. Yeah. In pump. And then, alright, so, well, we need a coordinate system. I guess it doesn't really matter right now. We'll just do this. And then we need some area vectors, all that good stuff. Actually, yeah, this is a flow problem. The one we did wasn't actually a flow problem. Which sounds funny, but it was like a thermo problem, but just in using fluid stuff, so. Then our V1 is gonna go in here. And our V2 is gonna come out here. Alright. Good. Awesome. I guess so we know our Q. Our head loss... Head loss is considered the net result of internal energy change, is what it says to me. Think about that, then look at your energy equation. Recognize what can be treated as head loss. Oh wait, yeah, what are the units, I guess? 8 feet. Very interesting. But I wonder, so... Are we saying that there's... I guess there's a Q dot out from the pump, even though we can't see it. Like, heat is coming out. And do we need anything else? I don't think we need anything else right now. Let's start with conservation mass. Alright, so we have 0 equals d by dt, CE, rho dE, that's 0, plus, we have two control surfaces, CS1, rho 1, 1 dot A1, that's going to be a negative, plus CS2, rho 2, dot dA2. And, you know, we're just gonna end up with saying rho Q1 equals Q2, rho Q2. Yeah. Right, so like m dot 1 equals m dot 2. Either way we want to write it, we can say Q1 equals Q2, we already kind of knew that, but we can say m dot 1 equals m dot 2. Either way, we're not we're not splitting a flow, you know, we're not losing energy in our flow, that kind of thing. Alright, so now we have to do our first law of thermo. Whoa, exciting! There's a lot of terms here, so we're just gonna, like, I guess write out the whole thing and then just start crossing stuff out. So... our first thing is gonna be Q in. So do we have any Q ins? Are we putting heat into this thing? I mean... we could be putting heat into the water, but like we're not putting heat into the pump, certainly. But we have a Q dot out, so that'll be our negative Q dot out. Plus, we have a work in from the pump. And that's going to equal d by dt of CV E rho, there's a little e, rho dv, steady state, so that goes away, and then CS1 E plus, oops, whoa, E plus, okay, where did I do this? How did I get E plus P over rho? Water won't heat up enough at the beginning to have a big enough temperature change to leak heat. Assume adiabatic okay, adiabatic environment is what I'm gonna assume. Which means very little to me, having not taken any sort of heat transfer class or thermo class. But I'm glad I took fluids first, you know, it's a lot better, I think. E plus P over rho is what? P over rho is like RT, like... oh, that's... I think that's our model for... no. What is that? What is that little thing? Did I write anything down about that? Oh. Yes, I did. Oh, I remember why. It's because we're changing the... so our work, right? There's gonna be work that's done on the fluid always by shear. Sorry, not shear. For pressures. So P over rho is that term. So that's it's our extra little work term there. So we actually want that in there very much so. This will be P1 rho 1 and then plus. Okay, so that's where we're going to be able to get our pressure difference out of those. And we'll have to say, you know, like assume that the pressures are probably like, I'm going to say the word coherent, not the right word, constant over the surfaces. Uniform, constant, whatever. Alright, so what can we get rid of? Can't get rid of that much stuff. Q out is probably going to be something that we can get rid of at some point. But, and we know W in, so that's okay. We need to start taking stuff out of these integrals. So these three things we can take out, probably, if I assume the right things. Uniform B over CS is, and then it's incompressible, we're chillin'. And our rho VDA is gonna be, I believe it's gonna be our Q, but we'll get there in a second. Okay, so we'll keep negative Q, we haven't done anything with that one. This one's chill. Equals, so what do we say we can take out? Rho. That's a known, that's kerosene. V1, and V1 equals V2, but, well, we'll get there. This is just M dot 1. Is it M dot 1? Yes. Yes. I'm gonna leave it as rho Q1 though. Just for... you'll see. It's a given, so I'll just leave it as that. And so then we have E plus P1 over rho 1. Okay, so I took out the A. I don't think I can take out the A yet. Otherwise, there's nothing to dA. So this will be V1. dA. 1. And so the same dealio here, P1, or P2. And we'll simplify it later. We know they're the same, it's okay. Probably should put subscripts on these until I change them. The height difference is going to be interesting here. Gravitational energy, I think, is one of the big things we're going to have to think about. Alright. EA2. Okay, so we're still going to do this. Now we get to pull stuff out. So first off, I'm going to just do rho v. Should that be a vector? Yes. Are these songs from a public playlist? I can share my stream music playlist. I think it's just unlisted. I'm gonna update it. It's a long playlist link, sorry. I'm gonna update it more over the summer, but it's got like, it's got Tulip and Pikmin and a couple Paper Mario games right now. I want to put Galaxy in there, I want to put Katamari in there, I want to put... Want me to do Tulip? I love Tulip. Tulip's so sweet. The E1 is our velocity squared, so that is okay. Oh, I know what I did. Yeah. Let me write that little. Here we go. So CS1. So V1 squared over 2. That's our kinetic energy divided by mass. Plus GZ1. Not really sure about how we want to define that. I'm gonna say maybe we actually draw our control volume from here. Wait, I'm cooking, let me cook. So that can be our datum. And then we know that it's 5 feet. So this is Z equals 0. This is Z equals, I don't know, Z2, Z1, Z2. I need to put Super Paper Mario music in there too, because I really like, there's some really good tracks in Super Paper. So this is 0. And then plus, I guess this is the weird little thing. So it's the internal energy. 1. Now asking about like this versus DA1, we're gonna get some fine things in the first one. And that's 0, so we don't have to worry with the 0. And then this one, I don't really know about how it varies over a control surface, but we'll be in for a treat when we assume things about that. So V2 squared over 2 plus GZ2 plus U2 EA2. Okay. And again, Q dot out plus W dot in pump rho V. Okay, now we can pull some stuff out. This will be V squared over 2 is straight up just, it's going to be V squared over 2 A. And then plus, I guess, just like the integral of CS1 of U1 DA1. This is probably like Q dot out and this are probably going to be like our head loss, quote unquote. Or it could just be this and this, so I don't know. I dropped a negative in here at some point. Oh, I didn't put a negative in here. This one should be negative. and this one should be positive. So this whole thing should be negative, which means that, yeah, our head loss would be that internal energy change, and the... Oh, and heat transfer. Perfect. That just gets rid of everything that we don't like. Oh, I also just got rid of these P1s. Awesome. I didn't mean to do that. That's actually bad. Okay, get out of here. Get over here. So P1 over rho 1, we're just chilling. We're going to say that the pressures are uniform across the thing, and then we'll have a thing, and then, yeah. Plus P2 over rho 2. This is going so great. Whoa. And, oh, come on. Please don't do this to me. Okay, wait, we get to draw funny images. My pen is not wanting to... What should I draw? I can draw Demi. What would Demi do? He'd be funny. He would go home. Evil Demi. I'll draw an evil Demi. The nefarious smirker. You funny little Demi legs. Okay, I have to do a little bit better job. Hey, my pen's back. Sorry, nefarious Damester. Oh wait, I can do a little... Oh wait, what was I assuming? Oh yeah, uniform pressure. My assumption lists are like the longest thing ever, I'm so sorry. I'm gonna just scooch this. Maybe minus that. Then, minus E1 over rho 1A. And then, plus B squared over 2. Ooh, A. Oh, those cancel out. I love that. I love that. Plus GZ2A. Yeah, okay. Plus CS2. Nope. I'm gonna do the pressure one next. E2 over rho 2A. Plus CS2 U2 DA2. Wow, okay. So we're gonna do this. We're gonna lump everything together. And we care about what? The pressure we care about the manometer, so we care about the pressure difference. So we'll lump everything together first. So negative Q dot out. I'm gonna move some stuff over there. So we want to pull out these internal energy terms. So they're given I guess they're giving us a positive value, so I'm gonna guess that means head losses between locations 1 or 2 are 8 feet. It's probably like 2 minus 1. So we'll assume that. So in this case we have 2 minus 1. So it means minus this U1 DA1. That looks like a V. U1 DA1 plus minus, yeah, there, and then plus PS2 U2 DA2. It times rho V, which whatever, that's fine. Those are also two things we know. Equals what do we have left? So we have E2. We have, I'm gonna move this over as well. Minus GZ2A equals P2 minus P1 times... I've been getting rid of subscripts that were like that. A over P? Sorry, A over rho? I think. So then we end up with P2 minus P1. So, and that would be, we're gonna use our manometer as rho GH is the pressure the pressure at one place. So if we say P okay. So this is rho m g h 2 and this is rho m g h1. So h is h2 minus h1. So P1 minus P2, or negative P2 minus P1 equals MH2 minus H1. That means that there's a higher pressure on the right? Yeah? Yeah. Which makes sense, I guess. Maybe. I don't know, it's getting pumped. I don't know what that means, really. Well, okay, I know what it means. But, like, you know. Equals rho m b h. So negative of this, and then divide that by that. Okay, cool. Whatever. I think I'm just gonna get this, and then I can, you know, I can get that from that. Okay, so I'm just gonna do this. Negative q dot out. Wait, let's put our head loss. So this is negative and negative in terms of the head loss. So we're gonna say, we're gonna do this, we're gonna do rho b, and in Q's case we're gonna divide by rho. No, I can't do that. I'm gonna just call it head loss. I don't know if that is the head loss, but and then minus BZ2A. Because I don't know if, like, this, it seems to me like this would be the head loss, not this, but, like, I don't know how to get rid of this without doing something to this, you know? So, I mean, like, we could just say... We could pull that, we could pull the rho v out. But then we don't know, like, you can't multiply the number, like, a part of the number by the rho v. Multiply the whole thing or nothing. But that was the first law of thermo. Actually not too bad once you know what you're looking for. I did a lot of simplification, like, over a lot of steps because it was like, this is the first problem I actually did with this. But I don't think that's too bad at all. I think that's pretty good, actually. Well, that was, like, fast, which is great. Let me see. So we could do another one, but, like, it's fine. Let me see if I have any differential. Because I actually wouldn't mind doing a differential. It sounds really cool. I don't think... Wait. Post the midterm. No, he just posted the midterm. He didn't post the results. I guess I could just play some games too. Or we could do... I mean, I guess I do have to redo a lot of linear stuff, unfortunately. Your Catboy fucked up and he didn't orthogonalize a basis. So... we have to redo a lot of integrals. But it's okay because we did some stuff, even odd function stuff that like, oh my god, it's so much easier. It's so much easier. I don't have any Navier-Stokes stuff yet. That's fine. Yeah, let's take a crack at, let me pop over to math. We'll do a little bit of math, and then I guess I'm gonna play games. I mean, I don't mind playing games. It is a Friday after all. It's just weird because, oh my gosh, I see. What is this? What did I draw this? Is this the rotation matrix Q? That's so based, actually. That's so based. He is just like that, for real. Oh, I do have a new guy. I started making a page of all my guys. Oh wait, this 3/2 x minus... Wait, these are orthogonal. Oh, except that these integrals can be a lot easier than I made them. But I think these are orthogonal, actually. The 1x, 3/2 x minus 1/2 we did. And, like, you can factor out a 1/2, I think, and it becomes... Wait, maybe it's not a 1/2, maybe it's a 1/3, or maybe I goofed it. Let's see. Let's take a look. Let's take a look. But I might as well redo this anyway. It's piecewise continuous interval. It's very easy. Now that I know what I'm... Alright. We did this, we said that... Sorry, I just punched you guys. We said that... it's 1/3 3x squared minus 2. Oh my gosh. Hi Cosmo, how's it going? I should draw John Physics, divider of zeros and creator... Divider of zeros? Oh, John Physics? I mean, okay. I'll draw Mimi John Physics, because I actually... I take a lot of time to think about, like, when I draw creatures, or... Generally when I, like, okay. Let me explain my little head world here. So, like, every, like, thing that exists, like every concept in math or whatever, or physics or something, engineering, or not engineering, bio too, like, is a little guy to me. And, like, the higher up you get in terms of, like, the more overarching, the more, like, complex the guy is. So, like, math, for example, is, like, a very, very specific guy. Like, he's not, like, just a creature, he's, like, a guy. But, like, you know, something like, what's a good example of, like, something I could just, like, goof off with? Like, even functions is just, like, some little, like, thing. You know, it's just, like, a little, like, little thing. But yeah, like, John Physics definitely is not named John in my brain, and he would also, I would have to really think about what he looks like. This is even function. I don't know why I made his head like that. That's his hair. Don't worry about it. Riemann function head. He's gloopy. It's like a pompadour, but like gloopy. And he's got overalls on. No, he doesn't have overalls on. He has a little funny squirrel tail. Yes. But like, wait, draw it like that. There we go. I think I named... I think the lore was that there was John Welding. Hat where the flap thing is a vector line. Oh, I love making... yeah, whenever I design creatures and things, I always try to put in vectors and... Yeah, so like for my mechanics of materials, it's like... funny head shape, and then... He's a vector eyebrow. A fat neck, he's a bodybuilder. He's got that One Piece neck. Yeah, I like that. Hat where I like that hat idea, that's like fun. But like, how would, I mean, you could do this, but like in real life, how would you make that? It would be hard. You could probably do something else though. What could you do with a hat flap? There's some funny little things that people have done, hats, manufacturing wise. I always get very surprised when he's John Physics, he can do all. Yeah, I feel like the name that I go to when I try to make up fake names is just John. So we have John Welding. It's like Andy. It's just John. Physics Andy. Yeah, this is not Physics Andy. This is just some guy. This is Identity Theft Andy. Oh, hat stuff. I could probably figure something out if I thought about it. Vector John. Oh, Vector would be such a character. I could probably do a Vector. Not on stream though. There's some that I'm like, yeah, I could do that on stream. There's some that I'd be like, I want to take the time to like iterate on that design. This guy is cute though. That's so real actually. Even functions do look like that. It looks like a batter from off. Truly identity theft. See, you get it. Do I have to orthogonalize these functions? I'm gonna cry if I do. Oh wait, no. Wait, yes. I do? I don't? I think he maybe meant to have them be orthogonal? Did I write it as 1/3 instead of 1/2? It's also entirely possible that I did that. I think he meant to write it as 1/3. Oh. Wait, where did I do this? I don't know how to tell you guys, it's so much harder if it's 1/2 than 1/3. Yeah, I think it's supposed to be 1/3. 3x minus 1. I don't know why he would say it's 1/2. Did I start orthogonalizing this? Oh, I did. Look at me. Yeah, look at this. This isn't... What is this garbage? 61/6? Oh, poor Damie. They're past me. Did so much work. What was I supposed to be doing? Express the function as a linear combination of that. Fuck it, we ball. I'm just gonna do the 1/3. And if not, you know, like, then it's good practice. Yeah. Okay, so u1 equals 1, u2, it is actually orthogonal, u2 equals x, and u3 equals 1/3 3x squared minus 1. So all these are orthogonal functions to each other, which seems an insane thing to say, because why are they orthogonal to each other? Basically, we define something called an inner scalar, inner product, and we say that if that inner product is 0, then the functions are orthogonal to each other, which is sort of like a dot product, but it's just multi-dimensional. It works for functions. It works for many things. A dot product is an inner product. And so then when we want to, so we are trying to express the function f of x equals x squared minus x plus 2 as a linear combination of these, we just have to project this function onto this space of functions, which is really not too awful. So we say the projection of f of x onto S is going to equal, we're going to take the inner product of 1 with f over, so don't write it like that. That actually isn't the right way to write it. And then we're going to multiply by 1, and then we take the inner product of f x over x. Very important also that this is over a symmetric interval, because then we can use some trickety tricks to simplify our otherwise garbage that we would get out like I was doing before. But it's a lot easier to, I mean, like, this one is going to suck no matter what. As we define the inner product for functions, it is an integral. So, no, that's a fun time. Alright, do the easy one first. So for 1, okay, we're gonna get, and here's what I'm gonna do. So every even function, we can split the interval in half and we can multiply by 2. Every odd function, its integral is gonna be 0. So we're gonna say 2 from 0 to 1 of x squared. That's an even function. It's got a squared. And then plus 2. And I am multiplying this out. This is going to be multiplied out. And then over 2, because 1 is an even function, of 1 dx. And so then we have this times x, so we're going to bump everything up, which makes our lives actually a little easier here. Our zeros, so we're going to have x cubed, that goes to 0, minus x squared, so that stays, plus 2x, which is 0. And then over 0 to 1, x squared. And this is going to be just like negative 1 also, because x squared, which is nice. And then we're gonna get, okay, this one sucks forever. We can, no, we gotta multiply it out. That's fine. It's better than what I was doing before. It's less work. Oh, and he also gives us the, integral of p2 squared x, so that's kind of nice as well. Assuming that this is actually a correct thing. Alright, so the 1/3 I'm just gonna pop out. Who cares about the 1/3? Nobody. We are gonna have like a 2 times whatever this thing is. So if we do the first one, 3x to the 4th. And then we're gonna have minus x squared. Then we're gonna have negative 3x cubed, that's gonna go to 0. And x, which is gonna go to 0. Then we have 2 or plus 6x squared stay. And then minus 2 is also going to stay. So that's like, you know, it is what it is. There's some integrals here. We can cancel out the 2's, which is kind of nice. This is going to be on the top. We have x cubed over 3, 1/3, plus over 1. And this one is going to be -1. I love that it's -1. That's like absolutely gorgeous. Our 2's are going to cancel there, so it's going to be plus, what's that? 1 over 15? Is that right? Wait, 2 divided by 2 divided by 5, wait, that's like times 5 over 2. 5 halves. 5/3. Don't listen to me. Oh, I guess I could just do this. Okay, so 3x fourths, so it'll be 3 times 1 over 5 minus 1/3 plus 6 times... Oh, I guess I could have just done that. That would have been smart. What is that? 5 minus... Sorry, plus 5 times 1/3. And minus 2. Augers. Look at how much easier that is. Look at that. Oh my god, that's like gorgeous. We were gonna get like 15ths, but whatever. Now we might get worse than 15ths. Let's see. So 1/3 plus 2 minus 1. 1/3 plus 1, so 4/3. 5/3 times, what is that? 3/5. 9/15ths plus 25/15ths. Maybe minus 30/15ths. 4/3 plus, I don't know what that is. Negative, it's 4/15ths. 5/3 times 4/15ths. Maybe. Let's see. Negative 30 plus 25 is negative 5. 9 minus 5 is 4. Equals 12/3 plus 12/9 plus 4/9 equals, what is that, 16/9? That's something. I'm trying to print it. Don't print it, please. There we go. Look how much faster that was compared to the other thing we were doing. Well, also because I thought I had to orthogonalize the base. Well, I would have to orthogonalize the basis if, he did make a typo. I'm just assuming he made a typo. I'm not sure if he did. I should probably email him about that because, oh my god, that would be a really bad typo to make. Because then we have to orthogonalize the whole basis. Well, we don't have to orthogonalize the whole basis. It's orthogonalize a little bit of basis. Maybe he wants us to, though. I don't know. I wish I had known that before lecture so I could have asked him today. I don't play video. What if we played video game? Video game. I'm thinking of... We did like, that's like a whole big chunky 3... Well, the last one wasn't that chunky. The last one was also not that long, so... Neither chunky nor long. That's something to be chunky and short. Thermo one was short, actually. Relatively. Let's play a game. What game should I play? I don't know. I kind of want to play Oxygen Not Included. Although I do also have... What do I have downloaded? I have BattleBlock Theater downloaded? Do I even have arrow keys? Can I play that? That game is hard. I'm not very good. I have Hollow Knight downloaded? What? I'm saying downloaded like that because I have like no space. I have Deep Rock. I know I have Deep Rock. I could play Papa's Freezeria. I think I'm gonna play Oxygen. No one's surprised I played that game. It was good though. Come on, it was a good little. Yeah, I feel like I could explain some stuff too. I think I'm just gonna leave the other music on though, because the aux does not include music so tiny. Let me change my. Oxygen. Oh yeah, baby. Such a wait. That's a game called Oxygen. No, I don't want to play that game. Oxygen. There we go. There we go. There we go. Oh my gosh, poggers. Okay, let me load Lorbos real quick. Actually, let me turn off the audio real quick as well. Wait, when I put it at 0, there's like a sad dev face. Wait, let me show you guys. Oh, that's my Twitch. Okay, well, let's not put that up. Game capture. There's a sad dev face. Sorry. Sorry, dev. I want to listen to whatever music I'm playing. Okay, this is my awesome save. Don't worry, that's my really good one where I'm not dying at all, and all my dupes love me. Now, wait, why am I still in math? Get out of here. Oxygen. I don't know. Maybe it updated. Maybe it didn't. I don't remember where we were, what we were doing. Whoa! I need to make a now. I need to make a liquid lock. That's what we were doing. I remember now. There's so much natural gas there. I'm also realizing, like, I think we'll be okay on stuff for the most part. We don't, like, really need natural gas right now. I'm also not gonna build. Yeah, I kind of would rather be, like, I'm on coal on my other base, and, like, it's not really that big of a deal, but, like, also, low-key, I think it kind of is a big deal. I don't have that many hatches is the thing. What is this? Loot box time. Basic gunmetal shoes. Cool. Okay, so why are all of these? Okay, that's good. Oh, there's a lot. Oh, there's a lot. There's a lot. There's a lot. Okay. Oh my god, Catalina has 2 illnesses? Where is she? Wait, which one is Catalina? Wait, where is Catalina actually? He could die if I'm not careful. Okay, so, oh no, that's Ellie. There she is. So, that's bad. I also wanna, I think I wanna liquid lock this room. As well. Which, okay, let me think about this actually. Let's put a Mirthleaf seed there. Do I have space to liquid lock this room? So, liquid lock the way we were building it. I don't think it works like this, or the way that I built it, it didn't work like this. You needed to have another one here and another one here. It has to be like that, the way I did it, which is fine. I'm just gonna do it a little differently. We're gonna deconstruct this, and we're gonna do it like so. Okay, never mind. Deconstruct the one tile that they actually created. And then here, like that. Yes. And then we put the bottle emptiers like here. And then we can lock it. And so that takes like 5 tiles is the thing. 1, 2, 3, 4. I guess I could just have one entrance into this. I think maybe that's the better idea. We have one entrance into this room, and then one way is the liquid lock. And they just only go in one way. It would give us more space. Yeah, okay, so that's great that I have to just deconstruct all the stuff they spent building time on. but that's fine, whatever. And then we'll set up, so the liquid log, I want the bottom to be here, so I guess it'll look like something like this, like, it's so much, like, I can't overstate, like, how much easier it is to, like, have a liquid lock than, like, these, because these, like, they can just walk through, they don't even have to open a door, it's so great. But yeah, I mean, not great for, you know, anything else, but that's fine. Yeah, I also kind of might... I don't know. I kind of don't want it to be this big of a room. I think it would probably be more efficient if I didn't have it be that big of a room. You know? But I don't really know... Oh, these need to be... Oh, lol. Lol, even. Why is there water? Oh, I remember, never mind. Oh, there's a lot of slime lung down there too. Great, awesome, swag. Swag for everybody, truly. Poor thing. What are we doing temp-wise? Oh, so sweet and kind. How are we doing germ-wise? Exploration. Okay, so that kind of sucks, but like we can go, okay, we can go this way, that's fine. Okay, there's a lot of slime lung. I mean, we can go this way. Temp-wise, that's also whatever, it is what it is. I guess our plan of attack is sort of through here, and we'll go over here. It'd be nice to find a ice biome. Actually, we really need to not have our generator here, because this is gonna heat that up. So, where do we move it, is the question. I guess I can move it over here. This is probably the smartest place to put it. Ooh, a pufflet. We do like that. I can move them in here. I guess if I just, wait, deconstruct these. Oh, wait, this is perfect, actually. Just deconstruct all these. I don't even know if anyone can wrangle this. Oh, they can. Because in my other save, I have pufflets, and they are constantly starving because they're really dumb and they don't go to the polluted oxygen that I have. It's fine. I don't want to sweep any eggs. I don't think I have any eggs swept. Oh, I do. So don't do that, because what the issue with that is that you just get, like, I'm getting egg overproduction, which wouldn't be an issue if, like, I wanted to, like, eat them, but right now I don't really want to eat them. Oh, how do I have so much coal? Oh, yeah, I'm not. Two lone spots of polluted water in the water are, like, really annoying. It's funny, though. I don't think I have any dupes with allergies, which is why I think I had these hanging plants here. But I will put, I don't know, I'll put that there. It's fine. My base is so tiny. But also I'm not using the space very efficiently at all. We need to move the generator over here for sure. I really wish I didn't have a huge ass reservoir like this. This is such an inefficient use of space. I might try and at least divide it so that it's two. Like, it's so tall, it's even taller than, like, anything. Like, I mean, I guess it's, like, okay because, you know, like, at least we have water. Like, oh my god, you know what I mean? You know what I mean? I'm gonna start trying to cordon some of it off. They're gonna get stuck if I do this, is the thing, because they're dumb. Do that. Because, like, I also don't really want to have, like, I want to have a little thing here so that, like, you know, the ladders to the base aren't, like, leading to the reservoir. That's just like a dumb idea. Sorry. Okay, she's kind of silly. I did not need you to do that like that. Oh wait, yes I did. I lied. Wait, cancel. I need that, and then this. It's okay. She's not gonna be stuck unless she builds this wall, then she will be stuck. Which, you know, is something that definitely could happen forever. Also, I really need to get the natural gas out of there. I really need them to also build this oxygen checkpoint, I think, before we do this. Like, we don't need natural gas that badly. I'm gonna... okay. I'm gonna make this less priority. That's unreachable. Why did I put that there? Okay, so this is going along a little bit, and I can put the plumbing in at least. Ink. Poor thing. We don't even have... I can't even make a curative tablet. Oh. So evil. Some polluted oxygen around there. Oh, wait, move this little guy, please. Who's supposed to be doing ranching? Who's doing ranching? Someone doing, like, ranching high priority? Apparently not enough. Oh, I can do 37, maybe. We need to move them. I just don't want to have to, like, worry about them, you know. Oh, pays. Okay, this should be priority 3, probably. Sorry. Sorry, critters. Not trying to spend all my time ranching, because I don't have the dupes for that. I don't even know how these... I don't know what these are, or like what they do, but it's like fun. Wow. Awesome. I like it when I get the ones like, I can change the plants to that. And I think that's pretty cool, actually. I do like that. Oh shit. Oh, wait a second. Wait, I gotta BRB 1 second. Oh. Me when I have to deal with something. I gotta text. I'm probably gonna wrap up soon, though. I do have to do something, somebody, but it's not really that super huge. Where? Oh, wait, where is this? Really never texted. Sorry, give me one second. Okay, we're good. We're winning. We're winning. It's like when you like have to talk to a person who you've never really like. You have to like call a person for the first time that you never called before, and you're like, "Is it right?" And it's like, "Yeah, it's right. Don't worry about it." Okay, I need to figure out where to put this power, and I can't put it. I really don't want to put it. Why is there so much slime lung in here? What the heck? What the heck? Why is there so much slime lung in there? Wait, what? What is doing that? Is there something emitting it? It's like the polluted oxygen. Is it from here? Oh, it's from there. Oh no. Do I have I don't even have a deodorizer in there. Oh my god. Jesus Christ. Okay. Yeah, do that like very urgently. Where's all that power stuff? There we go. Like, I guess just here. Well, that also needs to be powered, I guess, too. Yeah, I think they can do it in that day. Wait, I gotta check one other thing. Sorry, gamers. Oh my god, there are 4 people here. POV. My spam mail. My spam mail? Oh. Maybe? Anyway. I have a lot of slime lung. We gotta figure out that slime lung. Okay, the slime lung, and then what are other issues? This is gonna make all my plants hot. Don't like that. That's bad. Bad design. I want to make this sort of the line here, I think. Just if I want to put another thingy mabobber. So, actually, why did I do that? That can be a pneumatic door. Oh, the puff got moved. That's lovely. It should be fine. I got rid of all the deodorizers there, which is good. What else? Let's see. That one should be there. There really should be one right by the door, but... Well, they're going. I really hope they built it. Sorry, 1 second. Because everyone is contacting me so much. Okay. They're going. They got this. I need to get rid of this stuff. I don't like it. It's bad. But I don't have enough. I don't have enough room for the transformers and the other stuff over there. There is space here, which I would much rather have. Wait, is there slime lung there? I mean, I guess I could put the transformers right next to the bathroom. We could do that. As goofy as that is. But I want to have the main ladder here. So it would have to be here. And that is approaching slime lung territory. Although it's just 2 transformers. Okay, so if I went to dig here, can I fit 2 transformers in the slime lung-less area? The answer is yes, we're gonna do it. 1, 2. That would be where the transformer is. I don't mind if we get a little stuff there. So we'll do like this or whatever. Is it weird that they have to walk through the bathroom to get to the power transformer area? Probably. Am I gonna worry about it too much? No. So for now, I'll just do that and do that. Oh, but there's no door there. Shoot. I would like to have a door. I mean, just so I can have, like, some semblance of thermal insulation. Maybe some. So it'll be a little, it'll be a little slime lungy. It's not that much slime lung. It's just just a little bit. Oh, don't worry about it. Don't worry about it. Don't worry about it, chat. It's fine. We already have a lot of slime lung over there anyway. It's a slime lung party, you know? Fun for the whole family. And so we'll set up the transformers. We were gonna have to reset up the power lines, but that's fine. And then batteries and stuff will go down here, so we gotta do that. Right now, I guess I can... That's what I want to have happen, but that doesn't really help anybody right now. So for now, we'll just have it go over like this, and then down, I guess. Wait, do I want the power? Yep, that's the way we're gonna do it. How slime lungy is it? Not that slime lungy, fine. Don't worry about it. Don't even worry about it. And then power, full. It's great. It's gonna be great. There's a tropical Pacu here who's gonna protect us. Protecting us from the me putting all my electronics directly below my farm, which is a bad idea. I kind of just need them to do this first, actually. This is important, but less important than this is right now. Okay, I just made that less important. Let's do a 6, and then... And batteries will be here, I guess. Oh, God. Do I have smart batteries yet? I have smart batteries. I can just use one smart battery. I'm not gonna lie, I think I just have one smart battery on my other save anyway, so... Oh, they're not gonna be able to reach that, huh? Oh, they're dumb, it's fine. I guess just that for now. Yeah, all of those are unreachable. Awesome. Awesome sauce. Well, I mean, I guess also... Put ladders here. There's gonna be ladders there anyway. This is such a funny little room. I guess I don't even really need to dig this out right now. Huh. They can just access the power from there. That's kind of funny. I can't believe I have so many ladders here. It's such a scuffed base. It's fine. It's fine. They're doing so well. I'm gonna save real quick. I'm gonna check. Alright, this is actually a little more. Right. We're winning. We're winning. Yeah. I might have to end. Okay, so what I I do lion dance in case you don't know me and you're just here. Fun. I do lion dance, and we have a performance tonight that I was going to be drumming on, and then I ended up not being able to drum on it. But they need me to bring the lion head somewhere, so I might have to go and early. But we're almost the 2 hour mark anyway. I think I might just let this cycle run a little bit more, and then not all liquid water, and then enable auto bottle. I guess I don't really need 2. Really, the 2 is, oh my god, there's so much natural. We're gonna have to clean up, I guess, at some point. Oh, my music. Oh, there's no ladders there. That's not. This is like a semi-secondary issue. I mean, I guess I could do the power stuff for it too. Power runs. Okay, how does this work? Where do we want to put the battery? The battery, as I said, we're going to be here actually, so we do need to do that. But it's not too bad. I think we can do this. Put the battery here. A single battery. That. That's so funny. And then so for power, we need to run heavy watt wire here. And then the battery has to go through the transformers, which also needs heavy watt wire. Okay, fun. So get rid of this. Oops. Get rid of that, and get rid of this. And then we gotta build those plates. Like, I might as well, you know what I mean? Okay, awesome. I can't... well, it's... no, I need to have a tile there. God damn it! Can I just do that right now? Right now? Okay, that's kind of funny. What if I did that? Slimeling is it in that area? Really Slimeling. But I think I was gonna build through there anyway. Yeah, I was, so it's okay if I put a heavy watt plate there. Well, there. Heavy watt joint plate here. And then we say heavy watt wire, yeah. So pink, and then this. If I flip this around, then I can finagle it, I think. Oh yeah, I can. Oh yeah. Oh yeah, I can. Like that. And then out of the transformer is fine. And then... like that. And then another transformer. Let's go. And then wire, and then wire, and then wire bridge. And then wire... wire. And then wire. Yeah, like that. Yeah, like that. Okay, and the battery's there. Yep. Yes. And then I can build a, you know, just keep the bathroom looking nice. Very important that that stays a bathroom, actually. Right now it's a washroom and it's giving us a morale bonus. I would like to keep having a morale bonus. There's so much natural gas. I hope it's denser than, I think it's denser than oxygen. Well, this is good. This is liquid, that and 6. I would like them to auto bottle. Quite a lot of natural gas going around, though. which is not the best. These I don't want turned on yet, actually, ironically. Okay, I think I'm gonna call it here. Still save as. Save. Good. Good. Thanks everybody for hanging out. I know I was doing a lot of different stuff. Oh, that's me. Look, that's meta. Yeah, I was doing a lot of different stuff, but thanks. Oh, it was. Okay. Yeah, I'll be back Sunday, and yeah, we'll do some linear analysis stuff. That's all. All right, I'll see you guys later. Bye.